Hello learners, here Mr. G. We're going to make a video related to Newton's law of motion. Another video, Newton's law, we make a couple of them before, but this one is going to be a body, an object that is being moved up an incline. Okay, so let's do this question. This question is activity 4 from one of the grade 11's lessons at my school. Okay, say a boy is pushing an 80-kilogram box up the step driveway, which is inclined at an angle of 10 degrees. So the inclination here, let's just write the whatever we know here. This inclination is going to be 10 degrees, okay? And the mass of this object is equal to 80 kilograms. That is given to us. The coefficient of kinetic friction between the box and the driveway is 0.7. So I'm going to write it here. The kinetic of coefficient of friction is equal to 0.7. Calculate the magnitude of the force. They're asking you for the magnitude of the force, the applied force, that is the question mark, that the boy must exert on the box parallel to the driveway to push. So the force must be parallel. He's pushing it parallel to the driveway. That is an important data. The driveway to push the box with a constant speed. So the speed of the object is constant. See, the speed is constant. If the velocity is constant, the acceleration is equal to 0. And obviously, we're going to deal with Newton's first law. Since the moment you have this information, you know you are going to apply Newton's first law. So this is for Newton's first law of motion. Okay, so that is the first important thing we know here. So let's see. Remember to follow the step when we're doing this question. We read the question, we already wrote all the data, so we are not having to redraw the data, and we are going to draw now the free body diagram. In this case, I am going to draw the axis. Remember, I like the axis. So let me draw the axis and I'll be with you when the axes are done. Okay, here we have the axis. Now, let's have the following in mind. When we draw the axis of an inclined surface, the x-axis is going to be the same as the surface. So actually this surface here will be the x-axis. Alright, and all we have to do is to take it from there and place it into the Cartesian plane. And the y-axis, you're supposed to know, you must know from previous grade that the y-axis is always perpendicular to the x-axis. Okay, so that is important to know, and this is the axis I draw. Okay, so let's represent the forces acting on that object. First of all, we have the applied force of the boy. We have the applied force of the boy. This is force applied. It's the force from the boy. Okay? Okay. The other force acting is the frictional force parallel to the back. Parallel to the back. This is the frictional force acting there. There is a normal force. Remember, the normal force is perpendicular to the surface. So this is the normal force. And then the weight. The weight is always straight down towards the center of the earth. Okay? So this one is the weight of the object. Now, that weight is in none of the axes. So I'm going to determine the component by taking the weight to each of the axes. Here we have the weight in the y-axis, and here we have the weight in the x-axis. Okay, those are the forces acting on the object and the component. Remember, if in the question they ask you to draw a free body diagrams, you cannot include the components, otherwise you lose marks. Okay, so here is the first part of the free body diagram. Now, what is important to know? The angle of inclination there will be this angle here. This angle here is the angle of inclination. Okay, so that angle there is the one that is 10 degrees Celsius, and obviously if that one is the angle, so is this one here, because they are alternate between parallel. Okay, so this is the free body diagram, and it's not a problem. If you draw the free body diagram, everything as from now should not be a big issue. Now, we have to calculate the force that the person need to apply on the box, so the box or the block move at constant velocity. So we're going to apply Newton's first law. Newton's first law. All right, we are going to use it in the x-axis. Why in the x-axis? Because the applied force is in the x-axis. So we are going to be working with the x-axis, and here are the forces acting in the x-axis. Okay, so we have that F net is equal to 0 because the object is moving at constant velocity. This is Newton's first law. What forces are acting on the x-axis? We're taking up the incline as positive because the object is moving in that direction. Is the applied force minus frictional force minus the weight in the x-axis, and all that is equal to 0. Now from here, we don't have frictional force. It's not given to us, and we don't have the applied force in the x-axis. So let's first of all get the applied force in the x-axis. Okay, the applied force in the x-axis, all we have to do is to use the angles and METs. Okay, so applied force, the weight in the x-axis is equal to, here we are, weight in x is opposite side, you can see it there, so it's going to be a sine. So is weight multiplied by sine 10 degree. Weight we don't have it still, but we know it's the product of mass and acceleration due to gravity multiplied by sine of 10 degree. So if we substitute the data here, we have the mass is 80. So the mass is 80 multiplied by 9,8 multiplied by sine 10 degree, and we get that the weight is equal to 136,14 Newton. This is the weight in the x-axis. Okay, so that number is there, but we also don't have the frictional force. So let's look for frictional force. Frictional force, the formula for frictional force is kinetic coefficient of friction multiplied by the normal, and here once more we don't have the normal force. Here we don't have the normal force. So where are we getting the normal? We go back to our free body diagram, and we see the normal is on the y-axis. So we are going to apply Newton's law in the y-axis. Okay, so now here, important, Newton's law in the y-axis. So what Newton's law can we apply in the y-axis? Still Newton's first law. Newton's first law says the net force is equal to 0. What forces are acting? The normal force minus weight in the y-axis is equal to 0. Normal force is equal to weight in the y-axis, which is equal to weight. You can go here, you see it's adjacent side to the angle, and therefore it is weight multiplied by cosine of 10 degree. If we substitute mass multiplied by acceleration due to gravity, cosine 10 degree. If we substitute here, we have 80 multiplied by 9,8 multiplied by the cosine of 10 degree, and the answer is going to be 772,08. Okay, Newton, please. All right, so now we have all the information to calculate the frictional force. Let's calculate it here. Frictional force is equal to kinetic coefficient of friction multiplied by normal. The kinetic coefficient of friction is given to us. It is 0,7, and the normal force was calculated is 772,08. So the frictional force is going to be equal to 540,456 Newton. So saying that, we can go back to the Newton first law and do all the substitution of all the information we have. Is the applied force we're looking for. So applied force minus frictional force, which is 540,456 1.56 minus weight in the x-axis, which is 136,14, and all that is equal to 0. So the applied force is equal to the addition of those two numbers, which is going to be equal to 676,596 Newton. So that is the question. That is what the question is asking for. I hope is understood. It's not that difficult. Next time we'll do another example regarding application of Newton's law. Okay, so thank you very much. Good luck, and we'll see you next time.